Today we're taking a look at the Tera 1000 power station by 70Mi. They're the maker of popular dash cams, so I thought I would take a look at this unit to see if it's a good option for you guys. We'll get the contents out of the box along with the power station so we can go through it. Now immediately I opened the pouch to see what was included, like this DC charger you would plug into your car, and then also the AC charging cable, but I kind of realized that was all. I was hoping to see maybe a solar charging cable that would plug into this Anderson or the DC charging, so I took a look inside the manual real quick just to check the packing list, and it didn't come with a solar cable. That'll look like this. It's an Anderson to an MC4 connector, so you can use your own solar panels, but 70Mi does have a 110 watt solar panel that looks like good construction, like several others that I've seen before, and this will come with the appropriate cable along with a 6-foot cable. And this particular solar panel actually has the ability to directly charge up devices straight from it, so you don't need a power station. You can hook up USB or USB-C cables. This unit comes in at just under 29 pounds. Now one thing I do like about this unit is it doesn't use an outside charging brick of any sort. You simply plug the cable into the back of the unit and then into the wall, and it'll automatically start charging. You don't have to turn it on. And then it'll show you your input power, estimated time, and then the battery percentage. And this has a very nice screen on it, one of the best I've seen actually so far. We'll go through some of the display options real quick. Like one is the auto turn off. If there is no load, the unit will automatically power off. That way it's not wasting battery while it's in standby mode. Then you do have the flashlight, which this turns on into a SOS mode. It's not super bright, but it does the job. And then this is where you would turn on your AC fast charge, which right now it's on the slow charge. So we're going to go ahead and change that. And then eventually we will see the input power come from about 200 watts on low to about 800 on high. We'll take a look at the DC charging, like this 8mm port. This is where you would plug in that 12-volt socket to provide about 100 watts of power depending. And this also can take a 200-watt solar panel, kind of like that of the Jackery. Or you can also utilize a solar panel with Anderson connectors for about 200 watts of solar, but you cannot plug in both of them at the same time. Your USB ports will provide 12 watts of power up here, 18 here, and then as you move over to the Type-C, you'll have an 18 watt and also a 60 watt output, and along with a couple of 5521 barrel ports, which can provide 13.6 volts, and your 12 volt socket is the only one that happens to have a cover, which I really like covers in all of my stuff. It just keeps all the dust and dirt and elements out. But this is basically just your 12 volt socket outlet, so that's going to provide about 10 amps of power. And then 320 volt outlets on the bottom for a total combined power of 1200 watts out. So now as you can see, it is fast charging. It's about 730 watts right now, which 800 is max through AC charging. Now one of the things I noticed is this doesn't have AC pass-through charging. It does have DC, but I find that the AC is actually more beneficial. In a scenario where you might have a storm coming and you want to hook up your fridge so the food doesn't spoil, basically, this would continue to provide power to the refrigerator, and when the power went out, it would just switch over to the battery side and continue providing power to your fridge like an uninterrupted power supply. So that is one thing I would like to see improved on this unit, is to have at least AC pass-through charging, because I find that more beneficial. But we'll continue on and go through some of the options in the screen. Like it does have AC output settings and also your language and a troubleshoot guide and more, but we'll go through some of the options like a timer. This is actually something different some other power stations don't have. As we scroll through here, we have the option to basically start this up immediately, or, well, if I went a little too fast, but if you go back, it has a 12-hour option, so kind of a neat little deal, but I prefer to have that actually on the AC side. Output settings, this is where we actually need to change it from 100 volts up to 120. So we'll move this down, hit the little cursor, that's where we want it for the United States. Then go ahead and click on the check mark, and now that's selected. Frequency is at 60 Hertz, which you can change to 50. And that pretty much kind of takes us through most of the important stuff, at least on this particular unit. Now, one thing I did notice was incredibly large intake port and exhaust port. These are much larger than most power stations of this size, which it also has a large heat sink according to the manufacturer. And when this turns on, I don't know if you can hear it, but this is super quiet. I have the microphone right up next to it, and as you listen, this is probably one of the quietest power stations that I've actually heard yet. And by keeping the unit cool, this can definitely extend battery life. We're going to go over the specs and then start our testing. This lists at $1,099 and has a 1,044 watt-hour lithium-ion EV style battery that has 1,000 cycles until it reaches 70% stated charged, can charge to 80% in 1 hour or fully in 2 hours, has a BMS that's made by Texas Instruments, which has a reputation of making quality products, and has an AC output of 1,200 watts or a 2,400 watt surge rating. We're going to go ahead and do our AC inverter test first, and so basically what we're going to find out is to see how well it does under just a standard load and to see what kind of voltage drop we get, and that'll let us kind of know a little bit about the quality of the inverter that they used. So right now we have 120.5 or 7 volts standing, and so we'll go ahead and hook this up to basically this hairdryer I have. This will provide almost 1,800 watt load. It is getting a little bit tired, so it's probably time to move on and get something else, but it'll still work for this test. I'm going to go ahead and slowly start this up, and so we have about 120 watts, and we'll boost this up to 400 in just a second. But you can see 120.5 volts, 120 watts, 127 on the meter, so pretty close. I'm going to go ahead and ramp this up to about 400, and now you can see that the voltage is still holding just fine. So we're going to bump this up a little bit higher to about, maybe almost 800 watts. So there we are at almost 800 watts, so about 60% of our rated power, 775 watts. Our voltage looks just fine. It's hardly dropped at all. Actually, it's maintaining perfectly fine. And now that we're up almost at 1,000, still holding pretty close to about 120 flat on the volts. So far the inverter looks like it's doing very well. I'm going to go ahead and ramp this up all the way to full power here in just a second. We can take a look at our watts, about 960. 930 up on the screen, and sometimes a lot of these never really seem to read the same as a kilowatt meter because that's what I'm pulling at least from the hairdryer, but frequency looks fine and our amperage looks fine. Power factor is fine, holding at just 1. And as we go back over here, I'm going to look at the watts and the amperage one more time just to see if we were to multiply 8 amps at, well, it should be 120 volts still. That should come out to where we were at, about 960 watts. Now we'll go ahead and go all the way up. And so almost 1,600 watts. And again, this is rated for 1,200 watts. And I'm just going to let this go. I'm not going to cut away. And we'll see how long it lasts until we have the overload light kick on or it throws some kind of a code. But so far it's doing fine. And whoever did a job on the inverter so far did a pretty good job, as I've seen other units that have more power than this, which I would only be able to get about 1,300 to 1,400 watts out of this same hairdryer because the voltage would actually be lower. So that means the output of our hairdryer would also be lower, but this is holding up just fine. So far, pretty impressive actually. I didn't actually expect this much performance, at least on the inverter side anyway, from this unit. But it's still going. I'm not going to cut away until it actually drops off and shuts down on us. So, and there it goes, which that's what it's supposed to do if you do overload it. So shut off, and overall, I mean, the inverter seems like they did a good job on that. So we'll move on to a capacity test. Okay, so I have this set up to do a DC capacity test, and I'm going to have this simulate as if you were using like your Cpap machine and this was plugged in, and about how long it would last. A lot of the newer Cpap machines can draw about 90 to 100 watts, and that would be on max high, kind of like the higher pressure, so that's what we'll set this up as, and then we'll see how long this will run it. So I have this 100% charged, the charging cable is unplugged, so now we'll go ahead and fire this up, and we'll kind of run through the information real quick, that way you guys can see. So 100%, here we go. Start the button. All right. Now as we take a look at these numbers, this is going to discharge it and keep track of everything for us. So at the very bottom, we have the amount of time that it will run, our milliamp hours or our amp hours later, the watt hours, which will be that purple number, 95 watts, almost 8 amps, and that'll be about 12 volts. So we'll come back in a few hours and see what this looks like, and according to this here, we're drawing about 105, maybe 110 watts, and about 9.5 hours, so we'll see what it looks like. And just like that, we're done, so we'll go ahead and take a look at the results. So now as we take a look, we have 809.3 watt hours. That's the amount of energy that we used. and 66.7 amp hours, which took about 8.5 hours to draw this all the way down. Now again, this did have a 1044 watt hour battery, which you never do get 100% out of that because you do have losses with the conversion and more, so this comes out to about maybe 75-76% efficient, which is about average for most of these at this size. So we'll recharge this to 100% and do another test. Now, two of the most common questions I get asked is how long can I run a Cpap machine or a fridge if the power happens to go out from storms and more, so I thought I would give you this real world test just to kind of show you. So I'm going to go ahead and hook up my refrigerator. This is again 100% charged, so we're going to go ahead and hook this up. And I'm going to use my fridge in basically a normal fashion. I'm going to open it and close it like normally, which you should try to reserve that if a storm does come. That way you're not in and out all the time. And my fridge is a little bit older, so it's not as efficient as some of the new ones. And when these lights are on, that's 100 watts or more just right there. So just opening the door is inefficient. So I'm going to see how long this lasts. We'll keep track of the time. And right now the fridge is up and running and the doors are closed. You can see it says about 6.5 hours, but that's because the unit is running right now. When it shuts off and it's on standby, it's not really going to use any power, except for the unit will have a standby loss of about maybe 1% per hour. I haven't tested that yet, but that's actually pretty common, so we'll see how well this does and how long it lasts. Now again, I was using the fridge like normal. It was also making ice like it normally would, and I got some water a couple times throughout the day. And now this is several hours into the test, and it says about 40%, and I'm about 6 hours right now. Okay, so we are now down to 1%, but look at the timer. It does say 1 minute, but as the BMS kind of compensates, there it gives us a little bit of extra time as it realizes we have a little bit more power. So at the moment, we've used about 800 watt hours. And now as we near the end, boom, it shuts off. So total runtime, we are at 10 hours and 47 minutes. We used 810 watt hours of power, which was almost identical to the DC test, but this gives you an idea of how long you can run a fridge under normal circumstances without really having to conserve at all. All right, so quick recap. Overall, excellent build, actually. Very nice screen, large cooling capacity, so this makes this unit super quiet, one of the quietest ones I've seen. So overall, the pros are pretty good. I mean, it's a good first run for 70 Mi, and they actually are applying for a patent for the inverter, which that did a great job. Now, as far as cons on this unit, really it's just the AC pass-through charging. I'd like to see that added. Also, an increase in solar input would be nice, and then also moving over to lithium iron phosphate batteries for increased cycle life. But overall, what do you guys think about this product? Let me know in the comments below, and if you are interested, there is a promo link, and be sure to smash the like button and subscribe, and until then, I'll see you next time.